Welcome to my channel, Dr. V.R.K. Reddy. Today I'll be discussing Cramer's rule. Cramer's rule is very important to solve the system of equations Ax equal to b. Especially we struggle to find the inverse of a matrix. It is lengthy process. To avoid the inverse, this Cramer's rule help us to solve the Ax equal to b on a condition that the determinant of coefficient matrix is non-zero. We can use this Cramer's rule to solve the system of equations Ax equal to b. We can easily handle the solution with the help of the determinant itself by repeatedly replacing the columns of A with the columns of B one after the other. Let's take you to the Cramer's rule with examples. Today I will be discussing about Cramer's rule. Cramer's rule is to solve the system system Ax equal to b. And X is the unknown column matrix where variables are placed in the form of columns, and B is called non-homogeneous or constant column matrix. So with this the setup is done. Now we have to find x. So where x is holding, where x is holding all unknowns. All unknowns. That is, suppose we take Ax equal to b, where A is a 2 by 2 matrix A, B, C, D, and x is equal to x comma y, small x and y, and b is equal to something like E and F. Then to find small x, we are replacing the column of A by the entries of B. Therefore, we are having here E, F, B, D. That is, to find the first element in X, we are replacing first column of A by B and finding the determinant of that resultant one, divided by the original determinant of original coefficient matrix A. Therefore, it is equal to determinant of AI divided by determinant of A, where AI you can see that this is I is equal to 1 case. Therefore, first column of A is replaced by entries of B. Similarly, if you want to find B first, y, if you want to find y is equal to AC, and now you are replacing the second column of A by with entries of B, then divided by the determinant of A only. So where I is equal to 2 here, I is equal to 2. That is, second column of A is replaced by elements or entries of B. This is how you are finding. You can generalize it if that the given system is a 3 by 3 matrix. So the coefficient. So you can generalize it if the given system is of the Ax equal to b, where is a 3 by 3 matrix, then you can write it Z is equal to determinant of Ai, where the first column, second column is from the A entries, third column is from the B entries, divided by determinant of A. Therefore, if you notice that all these places, the determinant of A is unchanged. So, denominator is determinant of A, fixed all the time. Numerator is the form of determinant of Ai, where I is actually this I is the columns of A, the particular column of I is equal to 1, first column, I is equal to 2, second column, I is equal to 3, third column of A is replaced by B. So, this is how we are doing. Use Cramer's rule to solve the following sets of simultaneous equations. So, now we have to write the given systems of equations in the form of matrix equations Ax equal to b, where A is equal to 7, 3, minus 2, 5 is the coefficient matrix, and x is equal to x, y is the unknown matrix, unknown matrix that we need to unknown, we have to find x and y, therefore it is known to us, and b is the constant matrix or the non-homogeneous term. Why I am using non-homogeneous term? It is Ax equal to b, where unknown is multiplied, A is multiplied by the unknown x, but b is the constant, that is differently having a structure, therefore we call it b is a non-homogeneous term. Therefore, we are using this Cramer's rule to solve the system Ax equal to b. This is the coefficient matrix. Now, to find xy values, we have to use x is equal to determinant of 15 minus 16. That is, the first column of A is replaced by the B matrix, B column matrix, B entries 3, 5. Its determinant divided by determinant of A. Determinant of A is 3, 5. So, this is equal to 75 plus 48 divided by 35 plus 6. So, that is equal to 123 divided by 41. So, therefore, this is equal to 3. Similarly, to find y value, y is equal to, so now I am retaining the first column of A, because I have already replaced first column of A by matrix B to find x. Since y is in the second position, now I have to find y. Therefore, I am replacing the A. This is I is equal to 2. You can imagine I is equal to 1. Now you have to replace the second column of A with the entries of B, that is 15 minus 16 divided by determinant of A, that is. So, you can notice that determinant of A is constant, I mean that you have already derived, therefore no change in it, but in the numerator there must be a change. Therefore, we have to calculate this value. So, it is plus 30, which is equal to, you have identified x equal to 3, y is equal to minus 2. Now, you can verify, we can verify verify by substituting x equal to 3, y is equal to minus 2 in the given systems of equations to know that our solutions are correct or wrong, right or wrong. So we can verify by substituting x equal to 3, y is equal to minus 2 in the given system of equations to know that our solutions are correct or wrong. So how do you do that? We have the equations, given system of equations, 7x plus 3y is equal to is equal to 15, 7x plus 3y is equal to 15, minus 2x plus 5y is equal to minus 16. When x equal to 3, y is equal to minus 2, I can see from here 7 into 3 plus 3 into minus 2, which is equal to 25 minus 66, which is equal to 5. Therefore, this is matching with B's entry, first entry. And similarly, if you substitute x equal to 3, y is equal to minus 2, then you will be getting, this is minus 6 minus 10, which is equal to minus 16. Therefore, this is matching with the second term of B, second entry of B. Hence, our answers are matching. Therefore, it is correct. Our answers are correct. Next, moving back to a system of 3 by 3. For example, you have a system A11 x1, A12 x2, A13 x3 is equal to B1, A21 x1 plus A22 x2 plus A23 x3 is equal to B2. Then A31 x3, where A11, A12, A13 and so on, A33 are the part of the coefficient matrix, x1, x2, x3 are the unknowns, and B1, B2, B3 are the non-homogeneous matrix, or you can say that it is inhomogeneous entries of the matrix, where A is equal to A11, A12, A13, A21, A22, A23, x1, x2, x3, and B is the non-homogeneous matrix or inhomogeneous matrix B1, B2, B3, or you can say is that it's a constant matrix. To find x1, x2, x3, we have seen that x1 is this way we have written A1 divided by determinant of A1. What is A1 here? That is first column of A is replaced by the entries of B, that is B1, B2, B3, A12, A22, A32, A13, A23, A33 divided by determinant of A is A11, A12, A13, A21, A22, A23, A31, A32, A33. In other textbooks, I mean some standard textbooks may follow the determinant of this by this one divided by delta, where delta stands for delta stands for the determinant of a coefficient matrix. Del xi is equal to del x1 is equal to the matrix that is obtained by replaced the matrix. Del x1 is the determinant of a matrix that is obtained by replacing the first column, first column of A by B. So therefore we are finding x1. Once you find x1, you have to find x2. That is, in the same notations you can say that that is nothing but you are unchanging the rest of the columns except the second column of A. Second column of A you are replacing by the entries of B. That is, and whereas this is the standard notation for the determinant of A, B, C and so on. A1 standard, this is the standard notation. Delta is the standard notation for the determinant of A. Similarly, x3 is equal to del x3 divided by del, which is equal to third column of A is replaced by the entries of B. Now entries of B, that is B1, B2, B3 divided by denominator is unchanged in all those cases. Please do remember that denominator is always same, that is coefficient matrix determinant only we are using, nothing else. So now this is how we are finding x1, x2, x3 of a given 3 by 3 system. Now 3x1 plus 3x1 minus x2 plus 2x3 is equal to 12. If this is the given system, we are going to solve this system using the Cramer's rule. We have to write the matrix equation Ax equal to B, that is coefficient matrix. So we have to identify coefficients of x1, x2, x3. That is, what are the coefficients? It is 1, minus 2, 1. And again, once that is done, we have to move to the second row. So what are those? This is 2, 1, minus 1. And then once that is done, we are moving to the third row. That is 3, minus 1, 2. This is your coefficient matrix A. What are the unknowns here? It is x1, x2, x3. These are the unknowns. On the other hand, you have the constant matrix on the right hand side is 3, 5, 12. It is a column matrix. Now you can say this is, we have to find x. We have to find x, capital X. So how do you find it? We have to find x, we have to use the Cramer's rule, where x1 is equal to del x1 divided by A, del x1 divided by delta, determinant of A. We have to find x1, we are using the definition, that is del x1 is equal to find x1, we are using the formula that we have obtained earlier, that we have derived earlier, that is x1 is equal to del x1 divided by del, where del x1 is just by replacing column of A by B, first column of, that is 3, 5, 12, and then rest of the columns are unchanged. Divided by determinant of A. So this will give you x1 value. So that is going to be the determinant equal to 3. Similarly, to find x2 is equal to del x2 divided by delta, that is equal to, now you are replacing second column of A by the entries of B, and rest of the columns are unchanged in A. Therefore, you will be having only the second column we are replacing, that means 3, 5, 12 we are writing in the second column, and rest of the columns are unchanged, divided by determinant of A. So you might have noticed now the determinant of A is already calculated, that is 10. Only thing you need to find is that determinant of is numerator determinant is 10, therefore x2 is 1. Now you have to find x3, that is del x3 divided by delta, that is the third column of A is replaced by the entries of B. Those are 3, 5, 12 divided by determinant of A in the denominator, that is unchanged. So, we have to calculate the determinant of the numerator. The determinant of the numerator is 20. The determinant of the denominator is already you have calculated is 10. So, all these three cases, finding x1, x2, x3, all these three cases, determinant of the denominator is fixed. Only the determinant of the numerator, which is keep on changing, because you are replacing columns of A each time with each column you are replacing in the process of finding x, y, z or x1, x2, x3, these unknowns. Hence, x1 is equal to x1 is equal to 3, x2 is equal to 1 and x3 is equal to 2. This is the, how do you verify? When x1 is equal to 3, x2 is equal to 1, x3 is equal to 2, you take the first equation, that is x1 minus x2, 2x2 plus x3 is equal to 3. It must give you 3. Let's check that. That is 3 minus 2 into 1 plus 2, that is equal to 3 minus 2 plus 2, which is equal to 3. This is matching with the first equation, right hand side term. Now you can similarly verify the other equations also, that is 2x1 plus x2 minus x3 is equal to 5. It must give you 5 if you substitute. Let's check that. X1 is equal to 3 plus x2 is equal to 1 minus x2 is equal to 2, that is 6 plus 1 minus 2, which is equal to 5. This is exactly matching. Therefore, it is satisfying second equation also. You should check the third equation. So, whenever it is matching with all these three equations, then you can conclude that your solution is correct. There may be cases. So, when Ax equal to B is given, but B is a 0 column matrix, then X is going to be 0 matrix. All unknowns will be 0. Is the 0 will be 0 is the only solution. Is the only solution. Is the only solution. Because when determinant of A is non-zero, all determinant of Ai's are going to be 0 when B is a 0 matrix, because Ai's are obtained by replacing each column of A by elements of B, but elements of B are 0. Therefore, Ai's determinant is going to be 0 in each case. Hence, you are getting a 0 solution. Now, I would like to solve one problem that is on application based, and with that I want to close the session. This is the question, application problem. A commodity was produced by using 3 units of labor and 2 units of capital. The total cost is 62. If the commodity had been produced by using 4 units of labor and 1 unit of capital, the cost is 56 rupees. What is the cost per unit of labor and capital? Now we have to find per unit labor charge and then capital. So to solve this one, fix the per unit of labor and per unit of capital. So I am assuming let X represents the cost per unit of labor, Y represents the cost per unit of capital. If that is the case, we can write the given, because the given system of equations are 3 units of labor and 2 units of capital together cost 62 rupees. Therefore, 2x, 3x, 3 units of labor, 3x plus 2y is equal to 62. 3x plus 2y is equal to 62. 4 units of labor plus 1 unit of capital costs 56 rupees. 56 rupees. Now we are writing Ax equal to B, where A is equal to 3241 and B is equal to 60 to 56. X is equal to xy. So according to the Cramer's rule, we have to fix x and y value. So before that, what is the determinant of A? We have to find the determinant of A is equal to 3 minus 8 is minus 5. Determinant of A is this, which is not equal to 0, therefore you can proceed. What is the value of x? X is equal to determinant of AI divided by A, or x is equal to del x1 divided by del, where both are same, where AI is ith column of A is replaced by element of B. First column of elements of A by elements of B. And the second and other places we are not changing anything. However, the determinant is same for all those cases. So this is equal to 62 minus 112 divided by minus 5 that we have already calculated. This is equal to minus 50 divided by minus 50. It is equal to 10, and y is equal to I is equal to 1. For I, but I is equal to 2 here, divided by determinant of A, or y is equal to del x2 precisely by del, or here I didn't use x1 or x2, therefore I can say that this is del x divided by del, this is del x y, del y divided by del, that is second column of A is replaced by the elements of B, that is 3 4. Now the second column of are this, therefore this particular column of A is replaced by the elements of B, that is 62 56 divided by the denominator is unchanged. So this is equal to this is 16. Therefore x equal to 10, y is equal to 16. So this is per unit of capital is 16 rupees. 16 cost per unit of labor is Rs 10 rupees. Rs 10 rupees. So this solves the problem. You can solve the problems in the same manner for n by n system also. Suppose Ax equal to B, where A is n by n, x is equal to n by 1 and B is equal to n by 1. Then xi is equal to this, where AIs are the matrices obtained from A by replacing with column of A by elements of B. So we are doing repeatedly to fix those variables. So this is how we are finding these unknowns. This is how we are finding the unknowns. So unknown value, each unknown value by simplifying the ratio, where the denominator is fixed all variables calculation. Please follow my channel Dr. V.R.K. Reddy for more updates on mathematical content. Thank you.